We're going to look at another algebraic technique today, and this technique is called elimination. And the reason that this technique exists is because sometimes substitution is kind of a pain in the neck depending on how the equations are written. So we're going to look at a technique today that's helpful when the equations are written in standard form. So again, go with me on the steps. It's going to sound a bit confusing, but then as we do the example, it'll make more sense. So the first step is to multiply, if necessary, one or both equations to make a coefficient opposites. The second step is to then add the equations. The third step is to just finish and solve. And then the last step is to take the value you have and plug in to get the other number. All right, so let's use those steps as we do a basic one in example 1. We want to solve the system, which means we're trying to find the xy coordinate answer. And the first step says to multiply, if necessary, one or both equations to make one coefficient opposite. So you're looking for opposites in your coefficients. So here's what we have. We have the coefficient of x here is 1, and the coefficient of x here is 1. So those aren't opposites. But what we do have is we have the coefficient here of the y is positive 3, and here the coefficient of the y is negative 3. So, ta-da, this is what we want. We want one variable to have a positive and a negative version of the same number. So we don't need to multiply step 1. Sometimes you do. In this beginner level case, we don't. So what we're going to do is we can just go to step 2, which is add. So when I add them, I get 2x, and then these cancel because positive 3y plus negative 3y's cancels, or it eliminates. Wow, what a crazy name for this topic, elimination. So you get 2x equals, right, because the y's cancel each other out, 14. So then you do step 3, which is solve. So I get the x value is 7. So the x coordinate of this intersection point is 7. Now what I need to do is step 4, which is take my value, 7, and plug it in to get the other number. Now you can pick whichever original equation you want. I'll just take the top one. So I'm going to rewrite this top equation, but I'm going to write 7 plus 3y equals negative 2, because instead of x, I'm going to put a 7. So now you just get the other number. So I'm going to subtract 7. So we get 3y equals negative 9. So then y is equal to negative 3. So the y value of the intersection point is negative 3, which means that they cross at 7, negative 3. One way that you can check is you can plug 7 into the other equation and double check that you get negative 3 as well. All right, when we look at letter B, we are going to have to do that multiplication step. So let me show you how you would recognize that. You look at your x's, and I have a negative 6 and a negative 2, and those are definitely not opposites. Then you look at the y's. You have a 5 and a negative 4. Those are definitely not opposites. But then you think to yourself, how could I make one of them opposites? And this is kind of just where the thinking comes in. You say to yourself, how could I make either the x's turn into the same number or the y's turn into the same number? And if you multiply this bottom equation by negative 3, then when you distribute, that will turn into a positive 6. So you have to think about what number you need to make it opposite. The other thing that you could do is you could turn both of these into 20s, but that requires more work. So I'm going to multiply this bottom equation by negative 3, and so then I will get 6x plus 12y equals negative 42. Now I'm going to bring the other one over just so that way they're lined up. So I get negative 6x plus 5y equals 25. And now step 2, I believe, is to add. So these cancel. Negative 6 and positive 6 are opposites. And so I get 17y equals 25 plus negative 42 is negative 17. So that means that the y value of the intersection point is negative 1. So now I'm going to pick either equation and I'm going to plug that in to get the x value. I don't know, they both look kind of complicated, so let me just pick the first one. So I'm going to do negative 6x plus 5 times negative 1 equals 25. Negative 6x minus 5 equals 25. I'm not going to show the inverses, but I'll say them. I'm going to add 5 to both sides. So I get negative 6 equals 30. I'm going to divide by negative 6, so I get x is negative 5. So the x value of the intersection point is negative 5. One way that you can double check is you plug in negative 1 into the other equation and confirm that you get negative 5. All right, let's check out another one. In example 2, they ask us which approach could you use to solve the system. So pause for a second and see if you can figure out which choice it is. All right, it's choice A. Let's just kind of talk about the choices. Letter B says multiply the equation 1, this one right here, by 2 and subtract the equations. That's really close, but if you multiply by 2, this would be a negative 4, and which would mean that you would have to add them. So that one is wrong. Solve equation 1 for x and substitute the result in equation 2. You could do that. That's the substitution technique. But when it's written in this form, it's much more work to use substitution. So while C is correct, it's not efficient. And letter D, same reason, substitute negative x plus 4y for 6 in equation 1. Last lesson I said, well, if they both equal 6, then they must equal the same thing. So you could set this piece equal to this piece, but you're still going to have two variables, so it really actually doesn't help you do anything. The goal is to eliminate a variable. All right, in example 3, we've got a word problem. So you buy 8 hostas and 15 daylilies for $193. Your friend buys 3 hostas and 12 daylilies for $117. And what we have to do is we have to find the cost of each daylily. So it's a word problem, so our answer is going to be in words. They gave us the setup guide, so we're going to use this for both you and your friend. So let's do you first. So it says the number of hostas, which you got was 8, times the cost of the hosta, which we don't know, that's x, plus the number of daylilies, which I got is 15, or you got, times y, the cost of the daylily, and that equals 193. I'm going to just write that a little friendlier over on the side. 8x plus 15y equals 193. All right, why don't you try to write the other equation? All right, so here are my 2 equations, and I need to make something cancel. They're written in standard form, so I'm going to use the elimination technique. So here are my options. I can turn both of these into 24s, or I can turn both of these into 60s. It doesn't matter. Either way, I have to multiply both equations. I usually go with the smaller number, so I'm going to multiply the top equation. Watch this. I'm going to multiply the top equation by 3. And I'm going to multiply the bottom equation by negative 8. That way the top number will turn into a 24 and the bottom number will turn into a positive 24. All right, so here we go. the top equation is going to be 24x plus 45y equals, I don't know what that is, so I need to multiply 193 times 3. That is 579. And then the bottom equation is going to be negative 24x. 8 times 12 is 96, so that's minus 96 because it was negative. And 8 times 117 is negative 936. Now I'm going to add them. The 24s will cancel. 45 minus 96, or plus negative, is negative 51y. And 579 plus negative 936 is negative 357. Hopefully that goes in evenly. And it does. It is 7. So y is 7. That was the cost of the daylily. So do I need to find the cost of the hosta? No, I don't. Because if you go up to the question, all it said was find the cost of the daylily. If y stands for daylilies, then I just found it. I don't need to find hosta, so I'm done. But I'm actually not done because I need to say the answer. Because it's a word problem, so the answer is not y equals 7. The answer is each daylily cost $7. All right, down here there's a summary. This is all the techniques that we have for how to solve a system. So I would encourage you to highlight, to circle, to put a star. Do something over here because you want to make sure that you have a thing where you know to reference what techniques are helpful in which situation. If you have any questions, write them down and ask me when you come to class.